Salman, the screen is not sharing with you.
Yes, ma'am. I can't see the screen.
Screen, okay, let me reshare it. Just tell me whether it's sharing with you or not. Is it now visible?
No, ma'am. It's not visible
What,
yet.
what, can't you see this electric current written in our,
I can see your name. Amnaz nahi screen. That's all.
and
Nothing is
nothing
visible.
is
Yeah, it's blank.
okay? Just check your internet connection, Salman, because then only this
Okay,
occurs.
ma'am.
Just check your internet connection. If it is coming, no screen sharing, and the screen is just loading, so that must be because of the internet. I'll shut my video off now. Just see.
Ma'am, can you please reshare it? Yeah, I can see. Now I can see.
Now you
Electric
can see,
current.
no? All right,
Yes,
all
ma'am.
right. Now that must be because of the internet issue only. Okay, okay, Salman. So, what is the lesson currently going in your physics in your school? Right now, you must be having your summer
Ma'am,
vacations, no?
currently magnetism, chapter 5, magnetism chapter.
Okay, chapter 5. You are having your summer vacations right now.
Yeah, right now we are having summer vacation.
And before the summer vacation ended, this fifth chapter was completed in the school.
Yes,
All right,
but
all right.
I am having the doubt relating to the derivations.
Derivations, all right.
Yeah.
So, Salman, what we can do, since you also know that if we start from the beginning, very first from electric charge, then your syllabus will get delayed. So, what we can do, we can start from electric current, chapter number 3, and then
Okay, ma'am.
what all derivations. I'll be sending you my recorded lectures one by one. I'll add you on the WhatsApp group. I'll be
Okay.
sending you one by one WhatsApp those video lectures. So from there you can see chapter number 1 and chapter number 2. Few videos are there, you will be able to manage them. Just be sending them according to you. Whenever you are free, whenever you have time, when you are available, then I'll be sending it to you. Then what you can do, the derivation part at which you are stuck the most from both the chapters, we can have a class after your regular batch class, or on the weekend, or on at least Friday, one class we can arrange where we can cover it. Now in from current electricity onwards, you will be able to go. Clear?
Okay, ma'am.
So see, electric current, because as we've discussed, electrostatics unit dealt with the charges which are at rest. Means charges were at rest, so we didn't consider any topic like velocity, acceleration, all these topics. So today is a very short class. Think only hardly 10 to 15 minutes are left, so we'll just be having the introduction of this lesson. So when we discuss electrostatics, the first topic is electric charge. Similarly, in current electricity, the charges begin their motion. So as the charges are in motion, we can talk about the terms like velocity, acceleration of all the charges. Now in current electricity, basically first term that comes is the electric current. This is the first term. This is electric current. Now, what is meant by electric current? Basically, electric charge, just recalling it, electric charge is the basic or intrinsic property of matter that gives rise to various phenomena. Various phenomena include like electric forces, electric field, different formulas like this. So those are electric charges. Now, electric current basically means that amount of charges that flows within a wire. Wire means a normal, regular wire like this thin wire, normal wire. So what all amount of charges flow through this wire in 1 second. So if you measure, no, if let's say this is what? This is a wire. Fine. So at t is equal to 0, I have my timer. I have started the timer, and exactly at t is equal to 1 second, I stop the timer. So some amount of charges must have flown through this. That amount of charge is known as electric current because the time duration is 1 second. Or you can say, see, we have two words. Gradient word is also used, rate word is used. So rate, this term, rate means what? Rate basically means anything that gets divided by time or anything that changes with respect to time. So electric current also, it's the rate of flow of charges. The charges flow within the wire, no. So it's the rate of flow of charges. That's what we call as the electric current. And how can we relate this? See, electric current's formula becomes Q divided by T, rate of flow of charge. Fine. Salman, tell me one thing. In this formula, if I write T is equal to 1 second, what will be the relation between current and charge? Just put T is equal to 1 second in this formula. Tell me.
Yes, ma'am.
In this formula, just put T is equal to 1 second. T as 1. What will be the relation between current and charge?
Q by I.
Q and I both will be equal. Yes or no? If I put T as 1 in this if this denominator becomes 1, will I be equal to Q? Do you agree with this?
Yes, ma'am. Yes.
Yes. So that's the definition of electric charge, electric current. Electric current is basically the total charge that flows in 1 second, which we
Directly
call it.
proportional to charge.
Yes, right. Directly proportional to charge, amount of charge. So that's the rate of flow of charges, which we call as the electric current. Now, electric current's direction is very simple. It's very easy to remember. And current is most important because as you have also mentioned, and I was also about to mention it regarding the derivations. All the derivations of this lesson are based on current only. So if you've understood current, then we have drift velocity, then we have relation between drift velocity and currents. All these things we have to cover slowly and slowly. See, if it's a positive charge regarding the direction, I'll give you time to note the things. Don't worry about it. First thing, for a positive
Okay.
charge, let's say the positive charge is traveling, for example, it is traveling with v velocity in the right hand side. All right. For a positive charge, the direction of current is same as that of motion. Means if the charge is moving in the right hand side, towards the right hand side, then the direction of current will also be this, because this is a positive charge. So for a positive charge, direction of current will be same as that of motion. Means whatever is the direction of charge, no, that becomes the direction of velocity. Now, secondly, if it's a negative charge, just the opposite. If wherever the charged particle is moving, let's say this negatively charged particle is moving in the right hand side. So for a negative charged particle, current goes in the left hand side. So for a negative charged particle, direction of motion is opposite to that of motion. Direction of current and direction of motion become opposite. Apart from this, firstly, the definition rate of flow of charges. Secondly, the direction. For positive charges, it's the same as that of motion. For negative charges, it's the opposite. Last thing that you have to remember in the introduction and major portion of this is that if time interval is mentioned, time interval means like 0 to 8 seconds, 4 to 5 seconds, such time intervals or durations are given to you. So if such durations or time intervals are mentioned, then the current that we get, we take the difference of charge, we divide it by the difference of time. The current that we get is known as average current. This is known as average current. This is for what? A time interval. Time interval means initial time is there, final time is there. Like I will tell you, the class duration was half an hour. So time interval was half an hour today's class. So I'll say the class for me it started at let's say it was at 8:30. For you it must be around 6:30. So 6:30 to 7 is was your trial class. So that becomes a time interval. So if you had to calculate the current, you will use this formula. If you are given at a particular time, not interval, at a particular time instant, if it is given like t is equal to 4 seconds, t is equal to 3 seconds, or time is given as 0.004 second, any time period is given but time instant is mentioned, then you differentiate charge with respect to time. This is for, and the current that you get, this is known as instantaneous current. And this is done when you have at a time instant. Time instant. All right. Apart from this, you should remember that the SI unit of electric charge is amperes. So amperes will be used a lot. That's the SI unit of it. SI unit is ampere, which we write it with capital A. Current itself is denoted by capital I, the way I have written it over here. And one more thing you have to keep in mind, that current is a scalar quantity. It's the only scalar quantity that has a direction. So this question can also come in your objective questions. Otherwise, majorly those two formula for calculation of average current and instantaneous current becomes important. Fine, Salman, any doubts till now? Are you able to understand? Yes, Salman?
Yes, ma'am, I can.
All right, just note down all these points. Wherever you have doubts, ask me. Just note it down. I'll keep on scrolling it.
Ma'am, can you please scroll it down?
Done?